All right, guys. What we're going to do is we're entering into another thing, polynomials. So before we talk about polynomials, let's talk about what we've done so far this year. We've done linear, we've done quadratics, but all in the context of using the math equations to predict behaviors about things that we actually do. So on our virtual reality thing, we use linear equations to make predictions about glaciers melting. Right? And then at the beginning of the school year, I said that if I manufactured winter coats, there's certain months of the year, right, like the winter, where I'm going to sell way more coats than, say, the summer. So basically, in the real world, we use math. We model the math. We collect data. We come up with an equation that kind of looks like the data. And that's what all this is for. Okay, so we're going to do polynomials because polynomials are very robust. Polynomials have all kinds of shapes. And particularly today, we're going to do what's called a cubic. So a cubic is x to the third power, okay? So the parent function of a cubic is just y equals x to the third power, okay? That has a very specific type of shape. Well, let's just plug in the numbers and see what it is. So remember, if we use function notation, I'm going to zoom in a little bit here. If I use function notation and I say f of x is equal to x cubed, then I can plug in these values for x. Remember that f of negative 2 is equal to, wherever there's an x, I'm going to plug in negative 2, right? And just to kind of recap exponents, negative 2 to the third power is really negative 2 times negative 2 times negative 2, 3 times. So this times this is a positive 4. Positive 4 times negative 2 is equal to negative 8. So what that means is when x equals negative 2, right, when I plug this into the equation, I'm going to get negative 8. Now, this is a point on the graph, negative 2, negative 8. So I'm going to scroll down here. I'll zoom out in a second. That's a point on the graph, right? Negative 2, comma, negative 8. That's a point on the graph. Let me zoom out so you guys can see that a little better. Okay. And if you're a little lost, that's okay. Let me try to get it to fit in there. So now the next thing I'm going to do is I'm going to plug in. We've been doing this on our calculators, but you could do it by hand, right? You guys are smart enough. So wherever there's an x, I'm going to plug in negative 1. In other words, I'm trying to figure out when I plug in my, remember, this is an input, and this is the output. So my input is negative 1 to the third power, so I'm going to say negative 1 times negative 1 times negative 1. And so negative 1 times negative 1 is a positive 1. Then I'm going to drop down this negative 1 here. So when I plug in negative 1 to my function, x cubed, my output is negative 1. Also, just a quick reminder, this is the domain, and this is the range, right? You guys remember that from like the first month of school? What else do we call these things? This is also called it's the x, but I have the x written up here. This is called the independent, right, variable, and this is called the dependent variable, and I'm just going to abbreviate, depend. Okay. All right, so now let's see what the value is when I plug in my input 0, right? This is my input, my x value. I'm going to say 0 raised to the third power. What do you think that is? 0 times 0 times 0 equals 0. So that goes through the origin. Oh, you know what I forgot to do? We got to graph these things. So I have a point at, starting from the origin, negative 1, comma 1. Negative 1, comma, negative 1. So that's a point on the graph, negative 1, comma, negative 1. And then the next point is the origin, which is 0, comma, 0. Okay. I gotta slow down. I know my brain works way faster, and you guys gotta write it down and process it. I've been watching the videos, and I'm like flying through this. I was like, how can they keep up with me? I've got to remind myself that I do math every day, several times a day, over stuff that I already know. You guys are seeing it for the first time. Okay, so then let's keep going. I'm going to say f of, the other thing that's weird is this thing here. So f of 1 is equal to 1 to the third power, which is equal to 1 times 1 times 1, which is equal to 1. And then f of 2 is equal to 2 to the third power, which is equal to 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So I'm going to graph this point here, 1, 1. That's on the graph, 1, 1. And then 2, 8. That's also on the graph, 2, 8. And so my graph is going to, now I know I'm going to screw this up. So I'll give that, I got to kind of zoom in because I'll screw this up if I try to draw this on my tablet. But connect the dots, and that's the answer. Maybe I could do it with my mouse. Let's see. So I'm going to kind of come down through here. We'll graph it on our graphing calculators to get a better. And it kind of looks like this. That's not too bad. And so let's graph that on our graphing calculators to see what we get. So pull out your handy dandy calculator. And I'm going to put X. How do I get up to the superscript? Do you guys remember? This little caret symbol, right? This little symbol right here is the caret symbol. Then I plug in 3. I'm going to go to zoom and just hit standard. It just gives me the standard. And there it is. Go to zoom. Standard is option number 6. Did you get it? Okay. Then we're going to choose zoom standard, which is option number 6. Whoops. Okay. And then I'm going to hit trace because it'll put the equation in the thing. So let's take a picture of that. And this is what the graph looks like. Anybody have any questions on that? You guys getting it okay? Now, I want you to draw them by hand because sometimes you learn a lot by that. Yeah, well, me too. I'm not an art teacher, obviously. I still can. I'm just not doing it this year. I could teach physics, right? And so for physics, it's really good to draw the pictures of the story problems because then it helps you kind of figure out what formulas you need to use and stuff. And I drew a spaceship. In fact, there's a video of it on YouTube, and the kids were roasting me on this spaceship. I mean, they were relentless. And I was like, guys, have any of you ever seen a spaceship? And they were like, no. And I was like, well, then you don't know if this drawing is good or not. All right. So are there any questions on this? So we're not quite done. I'm just leaving this up here for a second. That's why I was telling you the stories about the spaceship. A lot of times when I tell you guys these random stories, you think it's just that I'm scatterbrained, which might be slightly true. But I'm giving you time to write stuff down. Can we move on to the next slide? All right. So now on this thing, let's zoom in and talk about what we know. Well, the domain, right? The domain is all real numbers. So we're talking about the attributes, and you may not remember that, but all real numbers. In other words, when I look at that graph, remember that all real numbers, this line right here, this graph, it will continue to go in this direction. In other words, our x values will go forever in the x direction. And up here, this will continue to grow. It's very steep, but it will continue to go in this direction. So there are no restrictions on the x values. So the x values are all real numbers. Also, let's talk about the range. How far up will this go, do you think? Forever. How far will this go down? Forever. So what's the range? Forever, or we could say all real numbers. So just remember, and I don't know if you guys remember this little R with the two lines, when I write it out like this. That means all real numbers. Yes, you kind of do. I've told you guys in the past not to copy charts down. And then what happens is when you take the test, you guys are told that those are the problems you get wrong. So I'll zoom out so you guys can see it a little better. Now the range is also all real numbers. That is a horrible R. Oh, we'll just start over. So that is also all real numbers, or sometimes you'll hear somebody say all reals, but it means all real numbers. In other words, there isn't an x or a y value that we can't plug in. Truthfully, domain restrictions only occur in a couple scenarios. You can't have 0 under a fraction, because then it's undefined, and you can't take the square root of a negative number. So if you have an algebraic expression under a square root or even an even root, any x value that makes that expression under the square root negative restricts the domain. Now the range is different. The range depends on the expression itself. So when we talk about the end behavior, in fact, let me just, I'm going to put this graph back over here on this side so we can talk about the end behavior so you guys can see it. The end behavior is saying that the end behavior is always referring to what is y doing as x approaches negative infinity or as x approaches positive infinity. So let's talk about that. Over here, this first line, and I'm going to go real slow, so don't try to write ahead of me, right? Like if you write the domain and all real numbers, the range and all real numbers, and now we're working on end behavior, don't think that you need to hurry up and write all this other stuff down. Just stay with me, and I'll go slow enough because I need to explain it to you too. So if I look up and everybody's looking down like this and writing like a crazy person, and then I explain this, you're going to miss the explanation. I'll go slow enough. If I go too fast, raise your hand and say, please stop. But it's not enough to just write it down. I want you to listen and pay attention and kind of be in the moment, okay? So anyways, look up as you write down. Because this is the important part. When I say as x approaches positive infinity, this is my x-axis. Positive infinity goes this way, right? So what I'm really trying to do is figure out what does the y value do? In other words, as I go to the right, what does my y value do? It goes up. Where does it go up to? It goes to positive infinity. This is really hard for people to understand the end behavior for a couple of reasons. Usually, it goes towards some sort of infinity, whether it's positive or negative. And then they get confused. Am I supposed to track the y or am I supposed to track the x? And the answer is yes, both. You look at the x and figure out what the y is doing. All right, different colors so that you guys can tell the difference. Now, when I say as x approaches negative infinity, I'm saying as this is x approaching negative infinity. We're going to the left. That's all that means. This means going to the left. This means going to the right. And it's based on what x is doing. When I go to the right, x approaches positive infinity. When I go to the left, x approaches negative infinity. But the question is, what does y do? What does f of x do? Well, as I follow the graph to the left, what is the y value doing? Yeah, everybody's pointing down like this. Down to where? Negative 10? Negative infinity. Remember, this is negative infinity in the y direction, right? So then we would say negative infinity. So that's the part that's hard for people. Zeros of the function. Zeros of the function is what we call the x-intercept. Where does it cross the x-axis? Right here. 0, 0. Ironically, though, we're looking for the x values of where y equals 0. So when we say zeros of the function, when x equals 0, y equals 0. So we really want to know when y equals 0, well, what x values does that happen? In this particular case, when x equals 0. Where does the function have positive values? Oh, man, I'm going to run out of colors. All these values right here, right? All of those, you have an x value and a positive y value. Okay? I really am running out of colors. So now, I guess I'll use black. So now, where does the function have, and when they say function, they're talking about f of x, right? That's what they're talking about is f of x. That's the y value. Well, right here, if I follow this part of the graph, the x values are here, and then I have a negative y value. Well, where does that occur? Well, we got to look at the x. It's when x is less than 0. Well, what does that mean? Y is less than 0. And when x is greater than 0, y is greater than 0 over here. Right? That's positive and negative in fancy math terms. Where is the function increasing? That should mean going up. Now, this is done from left to right. So you start with the furthest part of the graph to the left. Now, it's going to start over here at negative infinity. And it keeps going up. It's always increasing. You read it like a book left to right. That's an R, not a P. So you would say throughout the domain. It's always increasing through the whole thing. And it says, when is it decreasing? Well, it never decreases. I'm going to give you an example. If I have a graph, and we will run into these from time to time, and that graph looks like this. If we read that left to right, that decreases throughout the whole thing because it's going down. Okay. Last question. Is this odd or is it even? And we haven't really talked, well, we have, but you might not remember. I'm going to say this is an odd function, and we'll prove it in the context, because x to the third power is equal to negative x to the third power. And so I'm going to go back to the other table of values, and we'll talk about that. But I'll give you a second to fill that out. So everybody, I see some people writing some stuff down. Did I go too fast? A little bit? Okay, well, let me know. I can pretty much tell. Are you writing this down? You? I have to remember you guys have to write all the words down that I've just copied and pasted. What's that there that you have out on your lap there? You have pockets in your jacket. Put it in your ponytail. Yeah, put it in your bun. So I've got a funny story while you guys are writing this down. I had a freshman girl. She wore her hair in like a bun, and I said, "You got to put your phone away. You got to put your phone away. You can't have your phone in your hands. You can't have your phone in your hands." One day she came to class and she like put it in her hair, and she goes, "I'm not using it. It's not in my hands." And I was like, "You look ridiculous."
Okay, well, when I was younger, my hair would sometimes go long, but when it was sometimes long, I would gravel pencils in my hair so that way I would not lose them because then it saves everything.
You know I'm still recording, right?
Yeah.
Oh, okay. All right, go ahead.
For life advice, people listening.
Okay, yeah. The world needs to know.
The world needs to know.
Yeah, pencils. You can put pencils in your hair. All right, I dig it.
And I never lost pencils.
Cool.
Until I cut my hair.
All right, let me explain why this. Cool story. Let me explain why this is odd. Bless you. So, if we come back to this table of values, we say that this is an odd function, and we talked about it once before, but by the looks on your faces, I suspect you may not remember. An odd function, bless you.
Thank you.
For an odd function, if I say f of x equals, well, you're supposed to say f of negative x equals negative x cubed, right? Well, actually, you're supposed to say f of x, but I'm going to use the actual function, yeah. So what they're saying is when I plug in a negative value, it's going to be the opposite of what it is for the positive value. So notice that when I plug in a positive 1, what do I get for my y value? A positive 1. When I plug in a positive 2, what do I get for my y value? Positive 8. Now watch this. When I plug in a negative 1, what do I get? It's the opposite of this one. It's the negative of this one. When I plug in negative 2, so that's what all this stuff means. Also, odd functions have symmetry about the origin. So write this down in your notes somewhere. Just put symmetrical about the origin. Okay. And that one's a little confusing because when we do symmetry, we're usually like symmetry across something, but about the origin is an interesting thing. Basically, it's one way. I've heard somebody say it this way, but it's like if I take this line and rotate it 180 degrees, it'll be this line. Does that make sense? All right, it's time to go. Thank you for playing along at home. Any questions before I end the video? Any suggestions on where to keep pencils, pens? Any hairstyling suggestions? Your sock? Yeah, you can put them in your sock. Did you put it in your sock? Well, you have tiny ankles, so there's probably not room there.